Hi everyone. Today we will begin a new unit. The new unit is called Factoring and Solving Polynomials. The first lesson in this unit will be a review of factoring GCF and DOTS. GCF stands for greatest common factor and DOTS stands for difference of two squares. Let's review first what factors are. Factors are numbers or variables that multiply to another number or variable. Okay, here are two examples. We have 14x and negative 21x squared. This is actually example number 2, and I'm going to show you how we can find the greatest common factor between those two terms. Now, I have these charts written here so that we could write down all of the factors, but I think I'm going to use something called prime factorization to help. So let's write 14. First off, what two numbers come to mind when you first think of multiplying to 14? I would say 7 times 2. So let's write 7 times 2 and then times x. All right, can I break down 7 or 2 anymore rather than 1 in itself? The answer would be no. Can't break down x squared anymore. So that would be it. That would be all the prime factors of 14x. So now let's look at negative 21x squared. Actually, let's disregard the negative and make our lives easier. Let's deal with just 21x squared. So the first thing I think of is 7 times 3. And then times x squared. That'll give me 21x squared. But can't I break down x squared a little bit more? Isn't x squared the same thing as saying x times x? So we have 7 times 3 times x times x. Those are the prime factors of 21x squared. To find the greatest common factor, you just circle the things that are in common on both sides. So this side has an x, this side has an x. This side has a 7, this side has a 7. So the greatest common factor would be then multiply this 7 and x together. So the greatest common factor would be 7x. The greatest common factor over here would be 7x. So that's the easiest way to find the greatest common factor between two numbers. So let's look at number 1. We've got 4x on one side and we've got 4y on the other. So let's break down 4x on one of the sides. So I'm going to put I guess I'll put it up here. 4x means 4 times x. 4 can be broken down into 2 times 2 times x. Now, let's do 4y on the other side. So 4y would be, again, 4 times y. And 4 would be 2 times 2 times y. Since I can't go any further, you're just going to see which ones are the same. So 2, 2, 2, 2. And if you multiply the 2's together, so 2 times 2, that gives you 4. 2 times 2 gives you 4. That's the GCF. Some of you may look at this and see right away that the GCF is 4. So what you want to do is divide each piece by the GCF. Then you write the GCF on the outside, followed by an open parenthesis, and then you do some division. So the 4's will cancel here, and you'll be left with x. The 4's will cancel here, you'll be left with y. Now you could check to see if your answer is right by distributing this 4 back in. So 4 times x is 4x, 4 times y is 4y. It works out. Now example number 2, we already found the GCF with this little review up here. So the GCF, we're going to divide each piece by 7x. We write the GCF on the outside, followed by an open parenthesis, and we're going to do some division. So 14x divided by 7x. Well, these x's will cancel, and we're just left with 14 divided by 7, which is 2. Bring down the minus sign. Now we'll take 21x squared divided by 7. 21 divided by 7 is 3. X squared divided by x is x. Remember, you subtract the exponents and keep the base. And again, to check it, you could distribute out the pieces. Okay, let's do example number 3. So I'm going to break up 8x over here in one side. So 8x would be 8 times x. 8 is 4 times 2 times x. 4 can be broken up into 2 times 2. Bring down the 2 and the x. All right, that's one side. Now let's break down the x squared. X squared is the same thing as saying x times x. And that's it. So now let's circle what's the same. I've got 1x here and 1x here. That's it. There's nothing else that's the same that I can pull out. So my GCF would be x. So you divide each piece by x, write the GCF on the outside, followed by the open parenthesis, And now let's do some dividing. So 8x divided by x, these cancel. I'm left with 8. X squared divided by x gives you x. And bring down the minus sign. Again, you could distribute out to see that it works. Okay, let's do example number 4. So I'm going to break up 8xy. 8xy would be 8 times x times y. 8 again would be broken down into 4 times 2 times x times y. 4 can be broken down into 2 times 2. Then bring down the other 2, the x and the y. Alright, how about the 4xy squared? I'm going to have to put that up here. So 4 times x times y squared. 4 is 2 times 2. Bring down the x, and the y is y times y. So now what's the same? I have a 2 here, 2 here, 2 here, 2 here, an x, and a y. So my GCF would be 2 times 2 times x times y, or 4, 2 times 2, xy. So we're going to divide each piece by the GCF, and we're going to put it on the outside, followed by an open parenthesis, and do some dividing. So 8 divided by 4 gives you 2. The x and the y will both cancel out to 1, so those go away. The 4's will cancel, the x's will cancel, and all that we're left with is just 1y when we divide. Okay, let's try example number 5. Okay, some of you can see the GCF right away. Some of you can see that they're both divisible by 9, and some of you can even see the m's, that there's 3 on this side and 2 on that side. But again, if you need to write it out, feel free. So the 9m to the third is the same thing as saying 9 times m times m times m. The 9 can be broken down into 3 times 3 times m times m times m. Now let's break up the 9m squared. You could do 3 times 3 times m times m. Now see what's in common. I've got 2 3's, 2 3's, 2 m's, 2 m's. So 3 times m would be your GCF, or 9m squared. So we're going to divide each piece by 9m squared. Put the 9m squared on the outside, followed by an open parenthesis, and do some division. Here the 9's will cancel, and then m to the third divided by m squared is just m. Here, everything's going to cancel. So if everything cancels out and there's nothing left, it cancels to 1. So it would be m minus 1 would be your inside. Alright, why don't you try number 6, and then resume to find the answer. Okay, that should be your answer. Notice how I took the negative out in front, because you never want the leading coefficient or the number in front to be negative. So you always want to take that out, so in here it's positive. Okay, 7, 8, 9, and 10 are a little bit on the trickier side. You need to be able to see here that the 2x minus 9 is what's in common. Notice there's a 2x minus 9 here and a 2x minus 9 here. So what you want to do is divide each piece by the 2x minus 9. So you take out the GCF, put it on the outside, followed by an open parenthesis. Now you do some division. So here, this whole thing will cancel with this whole thing, and this whole thing will cancel with this whole thing. So you'll be left with x and a plus 7. So that goes in there. Let's try one more like that. Question 8. 2x times x plus 10 minus 10 plus x. Well, 10 plus x and x plus 10 are the same thing. Remember the commutative property of addition. So what we can take out is an x plus 10 out of both. So we take the GCF, put it on the outside, followed by an open parenthesis, and we're left with these will cancel, and these will cancel. So you're left with 2x and actually 1. There's nothing left over, but when you divide anything by itself, you get 1. So this would be 2x minus 1. Okay, let's look at example number 9 and 10. Example number 9 and 10 are a little bit different. The GCF, you want to say is x minus 4, but is it 4 minus x? And are these two things the same? The answer is no, they're not the same, because subtraction is not commutative. So what you want to do is take out one of them. So let's take out an x minus 4. So here, anything divided by itself cancels. So we take the GCF, put it on the outside, followed by an open parenthesis. We'd be left with x. Now, normally we would want to cancel these two things out. But can I actually cancel them? The answer is you can, but they cancel to a -1. So these cancel to a -1. So you have to take the 3 and the -1 and multiply them together. So that would be your last piece. Same thing goes for example 10. Your GCF is x minus 3. So you bring the GCF on the outside, followed by an open parenthesis. Just going to rewrite that. And these will cancel. You're left with 5x. These will cancel, but since they're opposites, they're going to cancel to -1. So that would be your only thing that would be left here, would be -1. Now, I know these last few are a little bit tricky. We will go over them in class tomorrow. Okay, now it's time to factor difference of two perfect squares. So first, let's do some vocabulary again. Difference means to subtract, and a perfect square is a number that is the result of two of the same numbers or variables multiplied together. So for example, 1 is a perfect square because it's the result of 1 times 1, two of the same things being multiplied together. 4 is another perfect square because it's the result of two of the same things being multiplied together. Same thing for 9, 16, so on and so on and so on. Now how about variables? X squared is the first perfect square variable because it's the result of two of the same things being multiplied together. X times x gives you x squared. X to the 4th is a perfect square because it's the result of two of the same things being multiplied together. So is x to the 6th, and so is x to the 8th. Now notice these exponents. What do you notice about all of the exponents of the perfect square variables? What do you notice about these? You should be saying that they're all going to be even. No matter what, they will be even. Now, what about its square root? So what do I mean by that? Like, if I took the square root of x squared, I get x, because x times x gives me x squared. If I take the square root of x to the 4th, I get x squared. If I take the square root of x to the 6th, I get x to the 3rd. So what do you notice? Well, let's try one more. The square root of x to the 8th would be x to the 4th. What do you notice about the square, the perfect square, and its square root? What do you notice about these exponents? You should be saying that they are half. So the square root's power is half of the perfect square's power. So we could say it's half. Just say that it's half for now. Okay, so let's try a few examples. They say, factor each expression completely. So you always want to check for GCF first. So is there a number or a letter that I could divide each of these by? And the answer is no, there isn't. So we're going to have to factor by a different method. And this method is called difference of two perfect squares. Difference means to subtract. So do I have a subtraction problem? Yes. And is it a difference of two perfect squares? Is x squared a perfect square? You should be saying yes because it's the result of x times x. Is 16 a perfect square? You should be saying yes because it's the result of 4 times 4. So the way that we do dots, or difference of two perfect squares, is we set up two sets of parentheses. Now, what goes in this front spot of the parentheses is what multiplies to give you that first item here. So you would put x times x, because x times x gives me x squared. Now what goes here in the back part of the parentheses is what multiplies to give me 16. And you should be telling me 4 and 4. So we're going to put 4 here and 4 here. Now the only thing that we need is a plus and a minus sign, because a positive times a negative will give me that negative there. Perfect, that's it. Now let's look at example number 2. Is there a greatest common factor that I can divide 16 and x squared by? You should be telling me no. So I know that it's a difference, because there's a difference, a subtraction, of two perfect squares. So let's set it up the same way. So now what goes in the front spots of the parentheses is what multiplies to give me 16, whatever's in the front spot. So we would put 4 and 4. Now what goes in the back end of the parentheses is what multiplies to give me the second part, which is x squared. So put x, and then a plus and a minus. So notice how example 1 and 2 are pretty much the same, except they are flipped. Okay, let's look at example number 3. Is there a greatest common factor that I can divide 5 by and 500 by? You should be saying 5. So we're going to have to take care of that GCF first. So just like we did in the beginning, we're going to write 5 parentheses b squared minus 100. And I got that by dividing those pieces. Now you want to see, can I factor this inside a little bit more? And you should be saying yes, this is a difference of 2 perfect squares. So let's go ahead and put 2 sets of parentheses. Don't forget to bring down the 5. Now again, what goes in the front spot of the parentheses are what multiply to give you b squared. So you should be saying b times b. And then what goes in the back end of the parentheses is what multiplies to give you 100. So you should be telling me 10 and 10. And don't forget the plus or the minus. Okay? Let's try example number 4. Is there a greatest common factor? The answer is yes. They're both divisible by 5 again. So 5 parentheses, these cancel. X to the 6th minus 25 y to the 30th. Now this one's a little bit harder. Is this a difference of 2 perfect squares? Well, it's a difference, yes. Is x to the 6th the perfect square? Well, what did we say we needed a perfect square to have? What do you notice about all exponents about those perfect squares? They have to be even, and its square root is always half. So let's check it out. Do I have even powers? 6 is even and 30 is even. Its square root is what goes in these inside spots, right? The square root of 16 is 4, square root of x squared is x. So we're just going to take half of these powers like we said we did before. So x to the 3rd will go here, because x to the 3rd times x to the 3rd is x to the 6th. And we're going to make sure we have a plus and a minus. And let's take care of the 25 first. So the 25 breaks down into 5 and 5. And y to the 30th, well, what's half of y to the 30th? Y to the 15th, y to the 15th. And don't forget to bring down that 5. That would be your final answer. Okay, let's try example number 5. So example number 5, first off, is there a GCF? Is there a number that I can divide a to the 4th by and 81 by? The answer is no. But is it a difference? Yes. Of 2 perfect squares? Well, 81's a perfect square, yes, because it's the result of 9 times 9. So I can go ahead and put those 9's in the back, a plus and a minus. How do I break up a to the 4th? Well, a to the 4th has to be a perfect square because it's an even power. How do we find those parts in here? Take half of it. So this would be a squared in this end, and this would be a squared. Now, can I factor any of these pieces more? Do I have any differences of 2 perfect squares? Well, I see a difference here. So couldn't this become ba plus 3, a minus 3? My next important question is, can I factor a squared plus 9 using dots? The answer is no, 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 no. This is not a difference, it is a sum. It's not a difference of 2 perfect squares, so you cannot factor it using dots. So this would be my final answer. Okay, let's look at number 6. So, is there a GCF between x to the 8th and 1? You should be telling me no. Is it a difference, yes, of 2 perfect squares? X to the 8th is a perfect square because it's an even power. Is 1 a perfect square? Yeah, because 1 times 1 is 1. So let's set it up as 1 times 1 gives me 1, and take half of the exponent, so x to the 4th, plus minus. We know that this is not a difference of 2 perfect squares, so I can't factor that anymore. But is this a difference of 2 perfect squares? Your answer is yes. This can be broken down into x squared plus 1 and x squared minus 1. Can I factor any more? Well, you should see here is another difference of 2 perfect squares. So this would be x plus 1, x minus 1. And now just bring down everything else. X squared plus 1 and x to the 4th plus 1. So that is your final answer. Okay, why don't you try 7, 8, and 9, and then resume the video to check your answers. Okay, number 7, the answer is that it can't be factored. The reason why is because it is not a difference of two perfect squares. So if you put c plus 5, c minus 5, that is not correct. Okay, number 8, you should have gotten m to the 3rd plus 5n to the 4th, m to the 3rd minus 5n to the 4th. Number 9, there was a GCF. The GCF was 9x, followed by an open parenthesis, y to the 20th minus 9z to the 12th. And you should have factored this again into y to the 10th plus 3z to the 6th, y to the 10th minus 3z to the 6th, and the 9x in front. Okay, please review all of the stuff that I just reviewed. This is a long video, so please make sure you come in with questions tomorrow.